This is a FCS2 flow cell on the Etaluma microscope. Here we have 8 individual components that make up the optical cavity for the cells. They are assembled without the need of tools. I'll start by turning the top upside down, exposing the inflow and outflow perfusion ports. When assembling a gasket is placed on the bottom surface of the top seal of the perfusion flow that passes through the optical cavity. The next component is a microaqueduct slide, the heart of the FCS2. It is a combination of an optical surface, temperature control component, and microfluidic guide having perfusion grooves to allow media to pass through the optical cavity. It is held separate from cells on a cover slip by a single gasket. The thickness and internal shape of this gasket enable the user to select or define the flow characteristics they want, either by selecting from the variety of already available gaskets or making their own. Cells which have been plated on a cover slip are then placed on the stack. The base is lowered on top and secured. To seal the chamber, simply turn it over and rotate the outer knurled ring to secure all the components. Perfusion lines are attached for supply and outflow. Under normal circumstances, these lines would already be attached to a source and drain. Next, an electrical connector is locked in place that carries both power and sensor information to the controller. It is then placed on the scope in the same manner as a 96 well plate. Therefore, there are no modifications necessary to the scope to accommodate it. All you have to do is just load it up and go. The addition of the FCS2 with its user-definable flow path and uniform temperature control will broaden the scope's utilization for research. The temperature controller is adjustable between ambient and 50 degrees C. It has a fast-acting channel for the microaqueduct slide and a second channel for the chamber base. Here we have a Delta T system on an Etaluma microscope. The Delta T is based on a 35mm cover slip bottom culture dish having integrated temperature control. The bottom surface of the cover slip is coated with indium tinoxide and a special geometry of conductive bus bars. An electrical current is passed through the ITO coating and is closed-loop regulated by a proprietary controller. The dish is placed in a SLAS stage adapter having a temperature sensor and electrical contacts to power the dish. There are numerous accessories for the Delta T to accommodate a wide variety of specimen types and imaging scenarios. Here is a cover glass lid that is used to provide an optical surface on the top of the media to ensure transmitted light images are free from contrast shifts that are due to fluid motion at the air-to-media interface. It is also available with perfusion ports. Next is a heated lid that encapsulates the atmosphere above the specimen, prevents condensation from occurring, and provides a port for the introduction of specialized gases. It too is available with perfusion ports. Another valuable accessory is the artificial membrane adapter that allows users to directly observe cells grown on the bottom surface of transwell-like devices. The membrane sleeve is simply placed in the adapter, then lowered into the dish where the specimen plane can be adjusted to the focal plane of the objective. The same principle is applied to a device that holds natural membranes so they can be observed. Both devices can be perfused apically or basically. For customers that need to cool their specimens, a simple cooling ring can be mounted to the stage adapter and flipped into the dish. Coolant lines are then attached to the reusable and autoclavable ring. When a dish is to remain open to the atmosphere and the customer needs to perfuse the dish, these handy hinged perfusion needle supports are used. The controller for the Delta T has many features not available with other systems. For instance, ambient to 37 degrees C in under 2 minutes. 0.1 degree C accuracy, no overshoot like typical PID controllers, real-time monitoring of dish temperature, reference probe temperature, integrated heated lid power supply, an imaging mode for Z-axis stability, and nearly instant temperature elevation for heat shock applications. It too has an analog I/O interface for programming and monitoring. For applications where the atmosphere above a specimen needs to be controlled, it is necessary to make sure the gas used is at 100% humidity. The Bioptechs humidification system humidifies any gas and takes it to the heated lid without loss. It is a dependable, convenient accessory that provides weeks of humidification to delta T environments. Gas is bubbled through heated water. The gas is then captured in the saturated airspace above the water and transferred back down through the heat source to be short coupled to the heated lid so that the humidified gas does not recondense. Here I am demonstrating the stage adapter for a stable Z specimen warmer. It is the only peripheral warmer that does not induce Z-axis drift to the specimen plane, an important feature for time-lapse imaging. It can be used with 35mm dishes, ICDs, and, with the appropriate adapter, the Bioptechs chamber slides. For customers that want to save on cover glass bottom dishes, we offer an interchangeable cover slip dish. It is made of a stainless steel threaded outer ring that holds a 30mm diameter number 1.5 cover slip and has a 25mm viewable aperture. The cover slip is retained by a polycarbonate threaded sleeve having an O-ring making contact with the cover glass. Therefore, media never touches the metal. It is fully autoclavable, and customers can make their own cover slip bottom dishes for only the cost of a cover slip. This is an adapter for Bioptechs chamber slides. It also provides Z-axis stability and is powered by a stable Z controller. It uses the same Z-axis stable design characteristics as the 35mm dish model. There is an optional heated lid that can be used with the humidification system. The controller is powered by an AC to 12V DC wall adapter or a 12V battery. It is adjustable from ambient to 50 degrees C. The arrow keys allow you to set the temperature, and the select key cycles through the stage temperature and temperature of a reference probe provided to monitor temperatures in the chamber slide or dish.